Okay, so let's talk about the steps that we're going to be taking in this module as we begin creating the basics of an HTML5 game. So of course, we're going to start off by creating our project. We're basically going to be using Visual Studio and IIS, but you could use whatever you wanted to host your project. The key thing is that we are just using an HTML page and some JavaScript, so we need some way to be able to host that. Then we're going to create a basic canvas. We're just going to get a canvas set up on our project and just make sure that we can display that canvas. Then we want to test things out and make sure that we can draw on that canvas. So we're going to start off by learning how to draw a basic shape. And then after we've drawn a basic shape, we'll convert that to drawing an image, because of course if we want to create a game, we need to be able to draw our sprite or our image on the screen. After that, we'll go ahead and implement a very basic game loop. We're just going to have an update and a draw, and we'll have to make it so that this game loop updates fast enough so that our animations look smooth. So we'll talk about how to do that as well. Then we're going to hit our first real challenge, which is getting keyboard input. We'll have to do a couple of tricks here to make sure that we can get our keyboard input when we want to check for it and not have to respond to an event. Of course, if you've used jQuery to get keyboard input before, you've probably set up an event handler, and we don't really want our game to respond to an event being raised. We want to be able to check and say, is a key being pressed? So we'll talk about how to do that when we get to that step. And then finally, we're going to make it so we can move the player. If we can get our keyboard input, if we have our game loop, then we should be able to move the player around by changing the position that we draw the player on the screen. And then that's it. We'll have the basics of an HTML5 game. Okay, let's go ahead and create our project. Now I'm using Visual Studio in order to be able to quickly host this with IIS Express, but you could use whatever you want. You can actually even run it from the file system, so you could just create a directory and drop your files in there. Now the reason why I'm showing you how to do this with Visual Studio with the web server is because you'll find that most of the HTML5 game engines are going to require you to actually host the web page on an actual web server. And the reason for this is because a lot of times the game engines will try to read something from the file system or try to get another resource like some JSON data to be able to show where the map is for the tiles or load things up dynamically. And you wouldn't really be able to do that with the browser's security preventing you from directly accessing the file system. So you'll want to make sure that you are hosting your HTML5 game in general. But like I said, in this case, you don't have to, but it's pretty easy to do this inside of Visual Studio. So what I'm going to do is just do a new project, and then I'm just going to do an ASP.NET empty web application. And let's go ahead and put this in the correct directory. And then we're just going to call this HTML5 game from scratch. And then I'm actually going to use NuGet here to get the latest version of jQuery. You can, of course, just copy the jQuery file if you want to, but it's pretty easy to do this here. So I'm just going to type in jQuery, and then we're going to install jQuery. So we'll just make sure that we get the latest version of jQuery. Now it's going to show up in our scripts, and then what I'm going to do is I'm just going to do add, and I'm going to add an HTML page, and we're just going to call this game. And I'm going to right click here, and I'm going to choose to set this as a start page. And this is just going to make things a little easier for us so we don't have to worry about switching over to that page whenever we run this app. And then in the body here, I'm just going to say hello world. And then I'll just save this, and let's go ahead and run this just to make sure that we can serve up our page. And you can see on my local host here, it says hello world. Okay, so the next thing that we're going to do is we're going to add a canvas and we're going to add our scripts to make sure that our project is set up and then we can start creating our game. So what I'm going to do first is add a canvas element, and we're going to use this to draw on. This is an HTML5 element that allows us to basically do drawing, which is really going to enable us to create a game, which we didn't have before HTML5. So we're just going to give this an ID, and we're just going to call this game canvas. And then we're going to set the width. We're just going to do 800, and then the height, and we're going to do 600. So that'll be our canvas. We're not going to put anything inside there for now. And then we're going to add a script. We're going to do script source equals scripts. And we're going to grab our jQuery. And then we need to put our type here for text JavaScript. And then we're going to add another script tag. Let's just go ahead and copy this one. And for this one, we're going to add a game.js, and we're going to make this file, this game.js file. So let's go ahead and create that file now. We're going to go into our scripts folder, and we're going to do add, and we're going to do a JavaScript file, and we're just going to call this game. And now we're set up here. So what's going to happen now is we'll display a canvas. We won't be able to see this until we actually draw something on it. And it'll be 800 by 600. Then we're going to load up jQuery and load up our game.js, and we can just start running from here. Now, there's a couple of ways you could have set this up. Of course, you could make it so that you do an onload and then run something from your game.js. But we're going to keep things as simple as possible here. So anything in game.js is going to get executed after our canvas is loaded up on the screen. Okay, so the first thing we're going to do is just see how to do some basic drawing on a canvas. We're going to create a border for our screen so that we can see where our canvas is on the screen. So I'm going to go into our game.js file, and I'm actually going to create a variable called canvas width. I'm going to set this equal to 800, and I'm going to create one called canvas height, and I'm going to set this equal to 600. Then what I'm going to do is I'm going to use jQuery to set this. So we're actually going to take the actual hard-coded width and height outside of our HTML and just do it here. So we're just going to do attribute width, and we're going to set this equal to 800, or actually to canvas width. And then we're going to do the same thing here for height and set this to the canvas height. Then we're going to go into our HTML and we'll take out this width and height. We won't need this. We could leave this in here if we wanted to, but it's probably a little bit nicer to do this programmatically so that we can control the width and height inside here. Now you could also create your entire canvas element in here. Some people do that as well, but we're just going to use the one that we created in our HTML. So then the next thing we need to do is we need to actually get the context that we can use to draw on the canvas. So the way we can do this is we can do var canvas, and we're going to set this equal to, and we're going to use jQuery to grab our game canvas. This is our canvas element, and then we're going to do 0 to get the 0th item in that array that comes back, and then we're going to do get context. And then here we pass in 2D, and this is going to give us a two-dimensional context to work with on the canvas. Basically, let us draw on the canvas as in 2D. So the next thing we're going to do is we're going to draw a shape. We're just going to do canvas dot stroke rect, and then we're going to specify the coordinates of a rectangle. So the 0, 0 will be the upper left-hand corner, or the 0, 0 coordinate, and then we're going to make the width be canvas width, and then the height be canvas height. And we'll go ahead and save this, and we can run this. And now, if we look at our screen, you can see that we have this rectangle that is the border of our canvas. So it's that simple to draw on the canvas. Now, you can just draw everything on the canvas using shapes. We're going to use images because we want our game to have those image sprites, but it's also acceptable to create a game that just uses shapes. In fact, I've seen games that have done that or have drawn everything using shapes like this, using essentially what's called vector graphics. It's really up to you. But next, we're going to try and draw an image on the screen. Okay, so let's go ahead and draw our image on the screen. Now, I already created a PNG file that represents the player. I'm just going to copy this into our project, and let's take a look at that real quickly. I just used a tool to do this called Sprite, which is basically a sprite editing tool that you can use to edit sprites, but you could create something like this with Paint. You could do it actually right here in Visual Studio, or you can use Paint.net or whatever drawing program that you like. The thing to do, though, is to make sure that you do have a transparent background when you save your image so that you'll be able to see what's behind it. Otherwise, what will end up happening is that you will have this big block here. You can see how this is all transparent. So that's the key thing with creating an image inside of a game. So what we're going to do is we're basically just going to make it so that we can draw this image in the middle of our canvas. Now, in order to draw the image, we do have to load the image up first. So let's go ahead and add our code to do that. So what we're going to do is after we do this part, we're going to do var image, and we're going to say equals new image. And then we're going to do image.source equals, and then we're going to give the name of our file, which was player.png. And then we'll have our image loaded up, so then we can just draw our image. So we can just do canvas.draw image. And we need to specify what the image is. So we're just going to say image, and then the position. So the X and Y coordinates of this. So let's do a bit of a calculation here. If we want to draw this centered in the screen, you got to think about what we'll have to do. So let's give it a first attempt. So let's say our first attempt to do this in the center would be canvas width divided by 2, and then canvas height divided by 2. So we'll go ahead and try that out. I'll save this, and let's go ahead and run this. And by the way, you don't have to stop your server. You could just refresh the page if you want to, just save your JavaScript. Now, what we end up with in this case is actually a blank screen. So we're not actually drawing the image. And you might be wondering why. Well, the reason why is that we don't have the image loaded yet before we try to draw it. So what we actually have to do is wait until an image loads. So if you've ever seen an HTML5 game where it says loading, and then you have to wait before you can play it, that's why it has to load up the images. So we can do this pretty easily. So what we can do is we can just do $ and then our image and use jQuery, and then there's a load here, and then we can add a function. So inside our function, what we're going to do is once this is loaded, then we'll draw. We won't draw before it's loaded. Now, if we go back to our page and we refresh this page, you'll notice that our image is drawn on the screen. Now, there is a problem here, though. Notice this is not exactly centered. And the reason why is because we're basically telling it where to draw the top left part of this image. So this is centered, the top left section, if you imagine this is a square here, but the actual image isn't centered. So we actually have to adjust this over. We have to translate this point over because we want our center to be at the center. That means that we basically have to subtract half of the height and half of the width from our image in order to draw it in the correct place. So this is a simple modification. So what we'll want to do is basically take our canvas width, and then we want to divide that by 2, and then subtract from that our image dot width divided by 2. So half of that. And then the same thing here for our height. So let's go ahead and move this onto a second line. And then we're going to take from here, we're going to subtract our image dot height divided by 2. So now let's go ahead and add our parenthesis here, and this one over here. And now if we go ahead and save this, and we refresh our page, you can see that our image shows up right dead in the center. This is one of those things that you have to get used to with game development, is adjusting things so that you're positioning things to the center of the sprite. And by default, most game engines, most ways that you draw on the screen really have you draw from the upper left hand corner or some kind of origin coordinate on your actual sprite. And sometimes you have to do that adjustment. Okay, so we're able to draw a rectangle, we're able to draw our image, but we need a game loop to really have a game. Nothing is going to happen in this game. We're basically just drawing a scene, but nothing could possibly happen unless we have our game loop. Remember, that's a key part of a game. So what we're going to do is we're going to implement a basic game loop. Now, the way that we're going to do this is we are going to figure out the frames per second, or basically how often that we're going to call update and draw. And we're going to use a set interval function in JavaScript in order to basically call update and draw that often. So let's go ahead and create a variable after we do our context that we'll call FPS, or frames per second. And let's go ahead and set this to 30. Now the reason why we're going to do 30 is because I believe your eye is somewhere around 24 frames per second. And so if you do 30, you should be able to see this without any problems. It should be a pretty smooth animation. Now, there are some cases where you might have a higher FPS and it will reduce some of what's called a motion blur, but 30 is basically gonna be fine for what we're trying to do here. So what we're gonna do is we're gonna call set interval, and then we pass a function that's gonna be called on a specific interval. And inside here, we're gonna call update, and we'll have to make an update, and then draw, and we'll make a draw function. And then we're going to say that this is going to be at 1,000 divided by FPS. So basically we're going to take our frames per second divided by 1,000, since that's the milliseconds, and we're going to basically determine how many milliseconds to wait before we call update and draw. And so we should call these every time at that correct frame rate. So it should be 30 frames per second. Now, obviously, if a lot of work was happening in between these calls, we might skip a frame. So now you know how your games work. Remember, when you're running a game and maybe your frame rate starts to get lower, that's because what's happening inside your update or draw inside the game that you're playing is actually causing it to skip some frames. So let's go ahead and create an update and a draw function. So we'll say function update, and we'll just leave this blank for now, and we'll do a function draw. And let's move our drawing code into our draw. So let's make sure that we go ahead and draw our rectangle, and then let's go ahead and add this code inside here. And the way we're going to do this now is, before we were basically doing this load and then responding to this, but what we could technically do now is we could basically just move this up. We'll move this up here so that we try to load up our image pretty early on. And then we don't actually have to worry about when it's loaded, because if we continually draw this on every tick, basically on every iteration of this loop, then eventually it'll be ready and it'll draw it. So it might not draw it for the first few times it goes through here, but eventually it will actually draw our image. So we no longer have to worry about that, because we're going from an event-driven model to really like a message pump. We're going into a loop, and we're going to be continually running inside this loop. So let's go ahead and save this, and now we should see the same exact thing happening on our screen. So if we run our code, let's go ahead and bring up our game, and then I'm just going to reload this, and we're still seeing the same exact thing, but now it's actually drawing inside of this loop. In fact, if we want to demonstrate what was going on here, let's go ahead and do something here. Let's do a console.log, and we'll say update. And this is going to be a little bit crazy. We're going to see this go pretty fast here, because remember, it's 30 frames per second. So, and then we'll put a draw in here. And now, if we go ahead and take a look at this again, and we open up our JavaScript console, I'll refresh this. You can see draw update, draw update. It's just going crazy here because it's running through that game loop that we created. Okay, so the next thing we're going to do is we're going to try adding a little bit of movement. But before we can do that, we need to do a little bit of refactoring here. What we're going to do is we're going to extract out the X and Y position of the player. So let's go ahead and create some variables to represent this. So let's say var player X, and we're going to set this equal to, we'll do it right here as the starting position. And then we'll replace that with player X. And put our semicolon. And then we're going to create a var player Y, and we're going to set this equal to this calculation here. So that'll be the starting position of the player. We're going to start them in the center of the screen in our case. And we'll do player Y. And let's fix this to say player Y. Okay, now what we're going to do is just experiment with moving things around before we actually add some controls to this. So in our update, let's go ahead and just make it so that the ship will sort of drift to the right. So how do you think we might do this? Well, it's pretty simple. All we have to do is basically say player X plus plus. And so every time update's called, we're going to move 1 to the right. And so if we were to just basically save that and then test this out, so let's try running our application, we should now see the ship is just going to the right. But we've got a bit of a problem here. See how it's drawing this big black line? We're not clearing the screen. In order to have an animation or some real movement, we need to actually clear the screen. We don't want to just draw the ship over itself. So let's go ahead and add that. What we're going to do here is we're basically just going to call clear rect before we do our draw. So we're going to blank everything out. Now, this isn't a very smart way of doing things. A good game engine is not going to clear the entire screen. It's just going to clear what's changed. We can get away with this because we're doing some pretty simple stuff. We don't have a lot of sprites on here. We don't need a lot of performance. But if you had a more sophisticated game engine, it would just update a certain portion of the screen. So we're going to just clear the whole canvas width and the canvas height. Okay, so now if we went ahead and loaded up our game, so let's go ahead and bring this window back over here, and we'll reload this. Now you can see we've got some animation. It looks pretty smooth. Here the ship is moving to the right. Okay, so now that we can draw our image on the screen and we can move it around and we have our loop running for our main game loop, we want to be able to get input from the user to be able to move that sprite around. That sprite's going to represent the player, so we need to be able to get input from the keyboard, for instance, to make it so that a user could move our spaceship around the screen. Now, in order to do that, what we're going to do is we're basically going to convert from an event model into a polling model. So what I mean by this is basically in JavaScript, normally when we're working with HTML, especially using jQuery, we usually respond to events. We usually, if a key is pressed, do something. But we don't want to do that because we want our game loop to basically be the same on whatever platform we're running on, whatever browser we're running on, or the hardware. We don't want it so that basically keys that are pressed at a certain rate or held down at a certain rate trigger events at different rates. And we don't want to have this other conflicting thing happening with our model of our game loop. So what we're going to do is we're going to be capturing key down events. And every time that the key down event fires, we're going to keep track of that key. We're basically going to keep a list of all the keys and set its value to true. And when key up fires, we're going to set its value to false. And we're going to basically be able to check in our update loop if a particular key is pressed every time that we go around in our little circle. And so we're going to be able to see if, for example, the user's pressing the left arrow key, we can move the ship left. If they're pressing right, we can move it right, up and down, and so forth. So let's go ahead and implement this next. Okay, so the way that we're going to do this is we're basically going to capture our key presses. So I'm going to go ahead and add here towards the beginning. We're going to go ahead and do this var, and then we're going to create this keys down, and we're just going to create an object here in JavaScript. Now inside here, what we're going to do is we're going to bind to the body. So our body of our HTML page, we're going to do a bind, and we're going to say key down. So whenever key down happens, then we want to call this function. That's going to take an E, that'll be the event, that'll let us know what the key is. And we're going to say keys down, and then we're just going to do e.which, gives us which key it is. And we're going to set this equal to true. Then we're going to do a similar thing here. We're going to do body, and we're going to bind for this key up event. So when we get key up, we're going to call this function. And inside here, you can probably guess what we're going to do. We're going to do keys down e which equals false. So basically, we'll be able to keep track of at any given time which keys are up or which keys are down, and we can do a check there in order to do some movement. So let's go ahead and go into our update. And inside our update, instead of just automatically moving the player, what we're going to do is we're going to check, and we're going to say if keys down 37. Now 37 is the left arrow key. It might be a little bit different if you're using a Mac or a different kind of keyboard, different keyboard configuration, but we can usually use something like this. Now we'll talk about how some of the game engines abstract this away when we start looking at a game engine, but for now, this should work for the most part. You might have to adjust this if your keys are different depending on your platform. But for Windows at least, this should work. So then we're going to do player X is equal to, or we'll do minus equal 10. We're going to move by 10. So if we're going to go left, and then let's go ahead and check for if the 38 key is down, which this is going to be the down key. So we're going to do player Y minus 10, and then we'll check 39, and 39 should be the right key, so we'll do plus on the X, and then we're going to check 40, and 40 should be the up key, so we'll do plus on the player Y. So let's go ahead and test this out. So now we should be able to move our player around with the keyboard, and I'll go ahead and reload this. And now if I move around, you can see that my ship is moving around. Now there is a problem here. You can see we're going off the screen. We probably don't want to allow this inside of our game, so we can fix that pretty easily. Okay, so to prevent our player from going off the screen, we're going to make a function called clamp. So we're just going to create a new function, and we're going to call this clamp. And this is a pretty common thing that you'll find in many math libraries and game engines, is this ability to basically clamp to a range. So the way this is going to work is we're going to pass in a number, and then we're going to pass in a min and a max, and we're going to make sure that the player stays within that particular range. They can't go outside that range. So we're going to return back, basically we're going to say x is less than min question mark min colon x is greater than max question mark max colon x. This will either return the min value or max value. If x is greater than the max, it's going to return the max. If it's less than the min, it's going to return the min. Pretty useful to have. So we're going to say player x is equal to, and here we're going to do a clamp on this, and we're going to pass in player x, and we're going to pass in 0 as the min, and then the max is actually going to be our canvas width, and see if you can guess what this will be. It'll be minus our image dot width. Not half of it this time, because we're not centering something. We want to make sure that our player can't go off of the screen, so we have to subtract that. Remember, we're working with the top left-hand corner, so if we just use canvas width, what would happen is we would be able to go just barely off the screen. We don't want any part of our image to go off the screen. And then we're going to do the same thing with player y. So we're just going to say player y is equal to clamp, and we're going to pass in player y. The min value is 0, and then we're going to have our canvas height minus the image height. And then let's make sure that this one is player y, not player x. We'll go ahead and save this. And then if we go ahead and reload our game, and then we try to move around, you can see I'm stopping here. I can't go past the edge of the screen. We've got this nice little boundary, and that's it. So now we have our basic movement in our game, and you could see how you could create a game from this. There's a lot that we're doing here manually, though. There's a lot of concepts here that we could really use a game engine for. So let's talk a little bit more about what a game engine will do for us next. Now, up to this point, we've done everything manually. We've been able to draw on the canvas, we've kept track of the position of a player, and we've basically been able to get our input and move around that player ourselves. And it's not all that difficult to do. You'd probably be surprised if you've never done any of this before with how easy that actually is. But this is a little bit tedious. If you can imagine, if we had multiple players, or if we had different enemies on the screen or different objects, trying to keep track of everything with single variables would be difficult. We'd end up creating probably a sprite class in order to encapsulate the X and Y position of some sprite on the screen. We'd end up making it so that the sprite knew how to draw itself. We'd start implementing a lot of this functionality that we have done manually for just one player. So it makes sense to have a framework that does this for us. Now, we haven't even gotten to collisions and to some other common things that you might do in a game, especially if your game has what's considered a tile set or a screen, different screens and levels to it. All of those type of things are sort of reusable elements that are going to exist in most games. So that's where we're going to benefit from a game engine. Also, remember I said that we weren't very efficiently redrawing the screen because we were redrawing the whole thing. A game engine could provide us a more efficient way of drawing our sprites and only refreshing the parts of the screen that needed to be refreshed. So even though things aren't too hard at this point, a game engine is really going to make everything a lot easier for us, and we're going to focus on the creation of the game, not on a lot of this plumbing code that we have here. Okay, so by now, hopefully, you have a pretty good idea of how to use the Canvas HTML5 element and how to draw an image on the screen, to be able to move that image around, and to use keyboard input inside of a game loop to be able to control a sprite or control our player in this case. Now, we didn't build out the entire game. As an exercise, you can try building a few more things. Perhaps try adding an enemy that'll move around by itself, or even making it so that the ship can shoot. Now, in the next module, we're actually going to see the purpose of using a game engine. We're going to basically re-implement what we have using a game engine, and then we're going to implement some more as we progress through the rest of the modules in this course, and we're going to build our complete game. So stay tuned, and we will be seeing how to use the Quintus game engine for HTML5 game development next.